song was so good. That song was so good. That song was so good. I'm gonna play it again because it was that good. Oh man. Alright, we're set up. Boom. All set up and ready to go. Alright, I'm not going to be streaming that long today. Just for a couple hours. I don't know what I'm going to work on. So, past few days I've been working on water. My sleep schedule has been fucked up, so I haven't streamed. I need to work on the chunking system again and get it less shitty. I also need to do a lot of things that are probably not going to be very fun, but I need to optimize things because right now we're kind of slow. But I'll show us where we are currently. On the Intel integrated GPU, we have transparent water. It was a labor of love. Hey Ahmed, hey Arya. It was a labor of love. I think it looks great. So as we can see, we have transparent water, which is nice. So am I, so are you what? So are you what? So that's pretty cool. If we bring the sun down, then that's what it looks like. Which is pretty neat. And that's cool. So obviously it reflects the skybox. So that's what we kind of did last time, was making that happen. Nice, thanks. When I was talking, yeah, I have no clue what I said. Zero clue what I said. So obviously we can change the color, but it's not going to change now because we have to basically jostle it. But that's cool. What am I going to say? What am I fucking talking about? All this is neat. The weird thing with this versus this is like, this is kind of the Fresnel and then this is more specular. So some of it is, I don't know. But obviously now that we have the water system so cool, now the chunking system becomes more obvious that how shitty it is, which is really not great. Like that is just not what you want to see. That is really not what you want to see. At this point with the chunking system, I'm just thinking maybe we just fucking scrap it, because I've been so sick and tired of this chunking system. I just don't know how to do it though. Like, I don't understand. Anyway, we are slightly slow to 60 FPS with all of this stuff happening, which is unfortunate, though I think that we can make it. I also want to make it so that when you're underwater, you have like distortion, which is fairly easy to do with in post-processing. The issue is I need to figure out when we're underwater or not, which is actually non-trivial. I don't really know how I'm gonna do it. Isn't the water a bit too crazy? Yeah, I mean, you can change the parameters with it, but for debugging, I wanted the waves to be crazy, but we can do that if that's what you want to see. Realistic water. So this is supposed to be 2.0 if that's what you want. And we can turn this down to about, I had this at 5 before, and then go to the vert and change this to num tiles per scale 1, and there you go. Now it'll be way calmer. As with anything, you can, you can change these parameters and make it exactly what you want. Hey, Abdel. But yeah. I don't really know if I'm going for realism per se. I did like the crazy stuff. I'm not making Earth, you know what I mean? It's kind of the goal to, I don't know, have crazy stuff, but as we can see, there you go. Earth like water. So, hope you're happy about that. But yeah. I think it would be more obvious if there was more of a difference in geometry, which I can also do. Kind of hard to do it. You could just turn off FPM and then just like make no, that's not what you want to do. That's really not what you want to do. You don't really want the frequency, you just want this to go to 10. Alright, that went negative. Alright, there we're kinda getting there. Okay, yeah, we probably need to touch it up more finely, to be honest. But we do have some crevasses, I guess. I'm the best. Keep going. Thank you. I don't know if I'm the best, but I think I'm pretty fucking great. Anyway, that's pretty cool. Yeah, I have a little bit of fun just playing around with this, not gonna lie. I've been just like, I just kind of like hang out and I just jump around, this is kind of like my fucking safe space. This is where I feel most at home. However, we do get lag like this, which is yeah, this is the cost of the water. This is the cost of the water. Is that eventually this GPU overheats is the problem. This is the overheating issue. Yeah. So we have to do some business today to try and mitigate this issue as well. So here's the funny thing about Intel and Intel integrated graphics. We can't actually even profile anything, by the way. We can't profile anything. So, yeah, we literally can't do GL begin query and GL end query. It doesn't allow us to. So, I think that there's a OpenGL profiling halt GPU. We can halt the GPU itself to profile it. GL begin query. Yeah, I mean, we might just have to profile it on NVIDIA for this reason. Because Intel, you just literally can't run the You can't. Why not use an actual profile like render doc? Yeah, I didn't consider doing render doc actually. That's a good thing. That's a good idea. I don't know if you can like really breakpoint it. Not breakpoint it, but like, you know what I'm talking about, like, because what I like to do is I like to actually do like timers based on everything specifically, like specific parts of things. But I don't have render doc anymore. I could get it. I just don't want to. I don't want to have to. I'm not gonna lie. I'm not like the craziest render doc fan, to be honest, but why the fuck is this 70 megabytes, bro? This 70 megabytes? Really? It needs to be that big? I don't know about that. Okay. Okay, what is the executable? Okay, dot/q render doc. And we're in here. Do not gather my statistics. What the fuck? Okay, there we go. Okay, we have render doc now. Okay. There is, you know, this is what I remember, is that this was light mode, and then, you know, we weren't that happy with it. But I just feel like I don't think that we got out of here. Oh, we did. There we go. Absolutely banger. Banger dark mode. Okay, so how do we do this? Vulkan capture? Fuck off, I'm an OpenGL guy. Okay, how do we do this? Select file to open. Okay, we're gonna open the file. Oh wait, that's a capture file, brother. I need the actual application. Or do I just attach to a running instance? Okay, let's just try attach to running instance. Let's also try to, I don't know if it matters for debug symbols. Okay, I don't really know what render doc is going to tell me, but sure. Let's give it a shot. Everybody always told me use render doc, and it's like, I don't know, bro. Bro, how do you do this? Bro, I don't remember. Oh, I'm just dumb. I am just fucking stupid, but that's alright, You can be dumb, I haven't used this in a long time, okay? So we're gonna be nice to me. You can be nice to me. Be quiet, come on. Don't be mean to me, Command line arguments. Yeah, we got none of those. We're just gonna hit the launch button. Please look it up. Bro, I'm not gonna look up anything. I already know everything. Why would I need to look something up? You could just tell me. Why? Like, that's why I stream. I know everything, like literally. Okay. Okay, print screen to capture. I'm alright, personally. I'm alright with that. Okay, so... Okay. So we're at 60 FPS, 59 FPS. Okay, so we're fine. We're actually goated. This is with VSync, by the way. Wait, so I'm like just goated at programming or what? I'm cracked. Performance counter viewer. That sounds like what we're doing. Sync with event browser. Sure. Brother, show me the performance counters. Resource inspector. Oh, right. We need to print screen. Where's my print screen button? All right, it's on my other keyboard. All right, we print screened it. Captured frame. Bro, I don't fucking know how to use this, to be honest. Okay, I might have to look it up. None of this is telling me anything. Okay, fine, I'll look it up. How to profile in render doc. Capturing a frame and using built-in performance counters. Yeah, I did that. Open capture. Oh, right. Open capture. Okay, where did it save it to? Where do the captures save to? Where do they save to? There's gotta be a thing here that says where they save to. Default save directory for captures. See, that's what I thought it was in share. Okay, we're gonna print screen again. Okay. And now we open the capture. Like, it's just not here or what? Maybe I don't care because this is at 60 FPS anyway. Did you even save the capture? I pressed F12, bro. I pressed F12. And it showed up that it saved the capture. Did I even save the capture? What are you talking about? Maybe I'm just not smart enough for this. See, it's right here. Oh. Wait, why? Why is that the design? Why is that the design? Why is that the design? What? I don't even want to talk about it. Why do you have to manually save it? I don't know, bro. Okay, so this is the that's the water. Yeah, that's the water, and then this is the meshes. And then this would be the shadow pass. And that is the water computation, is the FFT. Alright, that's cool. Do we have the time somehow? Like, is this time at the top? Huh. So this tells us how much time it all is taking. I would love there to be a performance counter thing so that I could see like the actual time. Okay. Let's keep reading. In the event browser. Okay. In the event browser. Okay. Oh, this is the event browser. Click the clock icon. Okay. Oh shit, there we go. See? Let's go. Google AI overview. That's awesome. That's exactly what I wanted. That's exactly what I wanted. Okay. So this is in microseconds. I don't know what the fuck a microsecond even is, to be honest. So the water isn't even that expensive. Look at this. 760. 4,000 for the shadows. Holy shit. 4,000 for the shadows? Jesus. Jesus. See, that's what I needed to know. That is really what I needed to know. Why is that so expensive? Jeez. Wow. Wowzers, wowzers, wowzers. So is this all collapsible? No, yeah, this is a part of the water. This is a part of the water. Okay. Wow, 4,000. I want to open up the other capture and then see. I want to open up the other capture and see if it's the same. Clock icon. Why is that not the default? Okay, but this one says 500. The fuck? You know what? We should have probably captured it while we weren't looking at the fucking ground. That's probably what we should have done. And by we, I mean me. So now I'm gonna do it when we're not looking at the fucking ground. Dude, this render doc thing is pretty neat. I feel like the UI is just kind of ass though. Like, half of the buttons, I have no clue like what they do. They just don't do anything. I don't know. I feel like it's probably kind of important for them to do something. Alright, so let's just look at the ground. It's the easiest way to do this. That we call print screen. Alright, and then we exit out. Oh, it automatically opened it this time. That's nice. Okay, so the depth pass really is not that crazy. The compute pass is actually expensive. The compute pass is 2 ms, is that it? So 2, 3, 1, which is 6. So about 7, 8 ms. Wait, no. This is 5. Oh, this is post-processing. Oh. So this is actually 5 ms. Holy shit, that's a lot. That's a lot. We still are 60 FPS though, which is good. But yeah, that is a lot. So 2000, so that's 6 plus 5, that's 11 ms. Plus any of the CPU stuff we need to do a frame, like collision is like 2. And then the mesh stuff is like 2. And then overhead. So that ends up being like 16 probably on the dot. Okay, well, it's good to know that that this is definitely the problem. It's the lighting for the water. Okay, well, that was cool. Shout out RenderDoc. Now, what to do with this information? No clue. Absolutely no fucking clue. It basically just told me what I already knew, which was that, why is my computer broken? Why is it so laggy? Okay. Anyway. So it told me what I already knew, which was that the water pass is super fucking expensive, but there's really not much that I can do about it because lighting water is actually expensive. So there's not much I can do about that, unfortunately. It's just slow on this GPU because this GPU sucks. So that is what it is. And by sucks I mean sucks. I mean this thing is Intel integrated graphics. So now there is probably some ways that I can mitigate it more, like doing the halfway actually in the vertex shader could be better. Holy shit, bro. It's Debussy, bro. This song. So good. So good. Shout out Debussy, bro. Yeah, there's not much I can do. I mean, sampling the texture inside of the fragment shader is kind of expensive, yeah. So there's that. This EXP is kind of expensive. I wonder what's a cheaper way to do the EXP. Here. I don't know, I just copied this, so I have no clue. There probably is a cheaper way to do it. Yeah, maybe we want to like just give that a test. Actually, let's just do that. So let's just do without this absorption. Yeah, without the absorption. Let's see. Oh, we can just open RenderDoc right from here. Without having to compile again. That's nice. You really need this on its own window. It's kind of a big, it's a big sort of, why do you have to do this? Why do you have to give it the, like, do you think that I work on different applications, bro? It's just one. I'm gonna get a copyright strike by WC himself. Okay, I did a capture. Okay, without any absorption. Let us see what we can see. So it's about 2 ms in general. It's about 2 ms. The cost of the absorption thing, which is massive, which is a lot. 2 ms is a lot. Yeah, it's a lot, yeah. Hey, but I mean, if RenderDoc says we're 60 FPS, I mean, then it's all good in the hood. Alright. Alright, I'm commenting it back in and we're moving on with our lives. Alright. Every time I close RenderDoc, it's like my entire computer like freezes. Jesus. So true. Okay. To be honest, from what we saw in the RenderDoc captures, we're actually kind of in good shape. Everything takes kind of a reasonable amount of time for what it does. So I'm kind of surprised, to be honest, about that. Yeah, I was thinking about passing in the halfway dir, but I don't think that the halfway dir is the problem. I think that this definitely is I thought I can probably look that up. Okay, so it says that we can use lookup textures, or what we can do is it's just apparently do exp2 with a 1.442695. Alright, let's try that. Let me try that. Bro, please work with me here, man. Okay. Let's see if we saved any time. No, we did not save any time. God damn it. Well, it's something we can work on later. We're at 60 FPS. We'll work on it later. We saved a little bit of time, I think. Probably like little bit of a millisecond or whatever. But whatever. Yeah, the water does take a while, huh? The water is 7 plus, or 2 is 7 ms. Which is a lot. It's a lot. Alright, let's work on the chunking system, I guess. Because that's my favorite. That's my absolute favorite. We all know it's my favorite. It's not my favorite. It's really not my favorite. Alright. So what are we observing? We're observing chunks that are popping out and dying, which is really not good. How to even... We're deleting chunks that don't need to get deleted. And so one does kind of think that, you know what we should do? We should get rid of some of this stuff, I think. Takes up a lot of space. Hey, dustmite, big fan of my work. Thanks. I appreciate that. A lot, yeah. I appreciate that. So my guess is that it doesn't have anything to do with this, but rather that it's the zero list. Oh. We didn't even... Oh, yeah, it is the zero list. So let's just take a look at if we get rid of the zero list, if it still is going to be popping in and out. Because so the zero list, for those of us who don't know, it is a hash table with all of the chunks that have given us 0 vertices in the past, right? It's how we get rid of empty chunks. The problem is that sometimes we get collisions and we end up with chunks. So we're gonna be laggy here, but yeah, so this is still happening even without the zero list, the popping in and out. See that? Now I'm trying to see what level. So it happens when it happens only when we go down to from 2 to level 3. That's the only time it happens. I think so. Okay, so it seems to only be when we go down to level 3 that we pop in and out. Okay, well, with that in mind, then things become we at least know where we're looking at here. So going down in LOD level, this is actually going up because we are going from, you know, higher to lower. It's actually up in detail. So lower is actually this. What is the most important advice you would give to someone to do what I do in C programming in OpenGL? I don't know, usually I just say like do a project or whatever, but that's kind of like whatever advice. Like yeah, of course do projects, but how do you do the project, right? It just takes a lot of time, you know? Like don't get discouraged. Because things take a lot of time. You know? Like it just takes a lot of time, like sitting here and doing the code. You know? It's got nothing to do with skill or, you know, smarts or whatever. It's just time. It's just you have to be willing to give it like the entirety of your life and your patience, you know? And then you'll become good at it, you know? But you've got to sacrifice a lot of time, you know? That's all it is. So that's my advice is that when you get stuck or whatever and you get discouraged, like, do you know how many times I get bugs where, you know, on this very stream where I like go 8 hours where I can't figure something out, you know? It just takes time, you know? Don't let anybody tell you that they would have figured it out faster or whatever. Everybody has it. Everybody gets stuck. Everybody struggles. That's the thing about programming. You kind of don't get to a point where it just is so easy for you. Like you're never gonna get to that point, you know. But yeah. Thanks for answering. Yeah, no problem. So when we're going down an LED level, or up technically, and we go up to 3, from 2 to 3, so 2 means that we had a child at 3, and now we are going up to 3. That means that it's here actually. That means that this child becomes the parent. This child becomes the parent. But we free it. So instead of freeing this, yeah, this is the child that then is going to be the new parent. So instead of freeing it, or freeing this child, we're relying on this chain already being correct, so freeing the parent here isn't really what we should be doing. Let's try that, because this now just frees the parent and we leave the child alone. Liver alone. Get it, liver. Get it, liver. I wish that this didn't happen. I don't really know how to get rid of it, to be honest. I don't use AI for coding, no. No, I don't like using AI. Or I mean, if I do use AI, it's, you know, to learn about something or, you know. But no, I'm not gonna sit on stream and use AI, no. It's kind of funny how that's become the norm, because like Just to think, like 4 years ago, no one used it, you know. So yeah, it still is happening. If LOD is greater than the replacement LOD, which is 3, then LOD plus equals 1. And then we go through. Oh. Replacement with no space. And oh, okay, so this is the bug. So this is if our LOD is greater than this, I'm gonna clean up the logic in a second here. But if this is greater than this, then we need to deal with it differently. If our LOD is less than, because if it's greater than, then we okay. Yeah, it's not that much fun. Yeah, AI is making dumb programmers even dumber. Yeah, I don't know. I don't like to knock AI because honestly, like I've used it, right? But like I don't like using it. You know what I mean? Like I think Google is getting worse because they want you to use AI. That's my conspiracy about it. Like, Google is, I don't know, the results nowadays are just simply worse. You're 100 times, I could probably make your entire code base tonight. Do you want to make a bet? Do you want to put money on that? Do you want to put money on it? Genuinely. Seriously. I mean, like, I don't know. Like, you would not be able to. No matter how many fucking tokens you spit at an AI, it will not be able to code this. No, it won't. I know. Because I've seen the capabilities. Hey, what's up, Alec? So we're only out of space if LOD is less than, because that means that we can't find a higher level of LOD. But for lower, or yeah. Alright, let's give that a shot. Yeah, I mean, I don't really like to knock anyone for using AI, but when there's a guy called Top G that comes in the chat and that is like, if you don't use AI, you're stupid and not productive, and like, dude, you write shit code. Your code is shit. I don't even need to see it, to be honest. Like, if you want me to be blunt, you know, you think your code is doing way more than it actually is. You're just fucking shit. Like, I don't know. So I don't like to say any of that stuff. I usually don't, but yeah, that was a specifically really big offender for me. It also happens when moving up from LOD 3, I think. Oh no. No, yeah, it's only going down. Yeah, this didn't actually solve the issue, which I'm surprised. I thought that this was totally it. Is this Ubuntu? No, it's actually Arch, or it's Endeavor. I have Debian on my computer that I stream from. The one that I code on is. Oh no, if LOD is greater than or equal to, then we skip this anyway. Oh, we skip it anyway. Oh. Oh, we're skipping it. Okay, well that would make sense. Any advice on PS1 game dev programming? Where do I start? If you're talking about actual PS1 game, then my advice is going to be very different. I don't know. If you're talking about like PS1 graphics, like style programming, you know, my advice would be different, right? But there was somebody a while ago that asked, like, if I want to make a PS1 game, where would I start, right? And I gave that person my code base, right? So I could give you my PS1 game code that I worked on this channel for, but yeah, this is almost worse now. This is almost worse now. Oh, I know what's off today. I never took my fucking medication, bro. I keep on forgetting because I wake up late. Anyway. Yeah, this seemed to make it worse. But now you don't even need this. Just want to get a triangle running on DuckStation. Yeah, I can give you my example code. I recommend you use PS Noob SDK. Right, the SDK from this guy. He's a genius. He rewrote the Sony SDK for PS1, and I highly recommend you use that if you want to develop for it. What does that mean? I don't know. It's I don't know. I think it's interesting. I think it's the vibe coders are very insecure. Like, genuinely, I think that's the problem, is that they're very insecure about it. And so when I say, like, I don't use, you know, AI, you know, or whatever, that I'm not using AI, then they'll just, like, say shit like that. Like, they'll be like, you know, they'll be like, well, you're stupid and dumb and bad at coding. It's like, dude, like, I don't know. It's just like it's. I wish that. Oh, voice crack. I wish that, dude. I wish that people knew when their code is bad. You know what I mean? Like, I feel like that's the problem. Is that vibe coders don't even know that the code is bad that they have. Like, AI just can't write good code. So I just like, it's just not whatever. Yeah, I'm surprised that this still isn't working. I thought that that was the bug for sure. Like, without a doubt. Or maybe it's that this. I'm trying to think also, like, how do I even debug, like, print this out or step through it or something? It's kind of hard. Maybe I should assert. Oh, but I already have this assertion here. I already have this assertion here. I already have that assertion there. What I think is happening is that it's freeing this chunk and then going to here. I wonder if we're not even getting into there. That's going to be my next check is, do we ever go from LOD level 2 down to 3? Okay, let's give that a shot. I need to print out the actual chunk position. Yeah, that's gonna be chunk pause. Am I making a space physics simulator? Yeah, so the first part of the simulator was in space, so I did an n-body sim. With accretion and all of that, and you can look back in the streams to see what it was in the beginning, but now it's turned into a thing where you can walk around on the planets as well. So I've been working on a chunking system and water physics and things like this to simulate the planets themselves. So all of that. Just graphics, really. Yeah, I'm having allergies. It's the dust. It's dust. It just... I need to, like, really dust this room really bad. I don't see any. Yeah, I should see way more. Like, I see a lot of creating new mesh at 3, but I don't see any moving mesh to 3. Yeah, I don't see anything. Maybe I should have gotten rid of the other printout so that it would be easier to see, but it would be happening here. So that's the bug itself. It's that we never actually go down an LOD level in the first place, and then we free it. Either that or we free it at 2. Huh. Okay. Just to prove that I'm not crazy here, if we do this, then we're surely going to move down an LOD level, and it'll be fine. I'm using Helix, actually. Is this for a game? Not really. Just a simulation project. It's a Helix. I prefer Helix because it's just really easy to set up, and it works very fast on my very bad computer. This computer that I run the stream off of is a Surface Book 2. And I do all of my graphics for Intel Integrated Graphics. Okay, so that proves it, right? That moving to LOD 2 works, but not 3. I wonder if we just never find the chunk at 2. Hold on. What? Oh. Wait. No, this is... Wait. Chunk world size times 6 would technically go outside of our... outside of our bounds of rendering of iteration. Oh, so that might be what it is. Oh. Okay, so it's... Okay, so since our chunk radius is only 5... Oh, okay. So we're simply replacing chunks that are outside of the radius. I see. I do see now. Because our radius is so small. Because I brought the radius down. Okay, okay, I see what's happening now. Yeah, I mean, that's kind of a problem that I don't know what to do about, though. That's hard. You never heard about it? Yeah, it's pretty good. I kind of hate the fact that you go to their website and it's like Helix, the postmodern text editor. It's like so pretentious. I think it's kind of bullshit, but that is what it is. I have to live with it. Okay, I'm just gonna bring back the zero list. It's already back. So yeah, so basically what's happening is that we aren't iterating over things, so they get freed instead of going down an LOD level. Yeah, you need a radius of at least 7 if you have a chunk, if your last chunk level starts at 6. Because you need to have a transition period for the chunks at LOD2 to go to LOD3. Otherwise, I don't know much about simulations, how much math and physics. You can do a lot of reading on the job. Nah, I mean, yeah, you can do a lot of the reading while you go. It's not one of these things where it's like, okay, so this is still doing it. That is still doing it. Yeah, it's not like I've like thought about a lot of physics or whatever. Like you know, when I want to implement something, I just look it up and then I try to read and then figure it out as I go. Yeah, this is disgusting. Yeah, this is way worse than it was before. Yeah, it still is level 3 though. That's gross. Yeah, when things go to, I don't think that any chunks at not LOD level 3 are problematic. Or maybe it is. It's hard to know. Yeah, that seems a lot worse, to be honest, than it was before. Let me see what the 824 124. Maybe I try bringing that stuff back. Yeah, I don't really know. I don't really know anything. I just kind of just do it and then learn as I go along. Like I kind of have no idea what I'm doing right now. I'm just trying to like think logically through it and try and figure out how to get through it. Like I don't really know what the solution is, but I'm trying to figure it out. You know, it's just that. Yeah, let's try with that. Maybe it was just like stale data that we weren't freeing and it like accumulated because I took out the logic that frees the connected things. I kind of doubt it, but we can try. Yeah, the problem with something like this is that it's not easily, like I can't just print out if the chunk is messed up, you know, then yeah, it's kind of hard to figure it out. Or I'm trying to make sure that it's only LOD3 that's yeah, it's now LOD3 but also going upwards in LOD level, I think. Yeah, like there. Yeah, I mean, like, thinking about it, I might just have to tear the whole system up now, which does really sound like it sucks, to be honest. Maybe there's just like some weird bug with it though somewhere. Wish that there was a way that I could tell if it's only LOD level 3. We can visualize it. I want to do that now. That's a good way to do it. Yeah, we have to do this. So, let's go based on this again. That's what we'll do. Yeah. Let's just do that. That will tell us which LOD level is which one. So I think LOD level 3 is going to be blue. And then LOD 0 will be red. And so if blue is flashing to water before it goes to something else, then we know that my hunch is correct, that it's LOD 3 only. Okay. It's kind of hard to see, but obviously holes. Yeah, so for example here with these holes in the ground, you kind of do start to think like 1, 2, 3, 4, 5, 6, 7, 8. We have 8 red, and then that's supposed to be the 9th, but we don't get it. Let's count the green. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's exactly the amount of green. Okay. Okay, so it's not a problem with LOD level 3, then it's a problem with how we're assigning children, because we're skipping these chunks because we can't find suitable children, because there's no free chunks in the LOD level before it, or underneath it. Okay. Okay. So I know what the problem is now, but I have no clue how to fix it. This thing I have no clue how to fix, because this actually the whole mesh system actually depends on this. So basically when we iterate through to find replacements, we also look for suitable children when we're slotting in a brand new chunk. The issue is that we may just not find children. So this is how we find suitable children. We look at the freeze score, is -99 or not. However, that's really hard to do. Maybe I should really just do a second. What is this? No, 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 no. Not what I want to listen to right now. It's like, what was that? Okay. I think I have an idea of what I want to do. I want to make it so that when we search for a chunk, when we're putting in a new chunk, and we're searching for a chunk, we need to make sure that it has a child attached to it. Really doing some nasty nesting here, so sorry, look away. We want to check if ID1 is this is supposed to be obviously this. Obviously, we're gonna do this. So if the ID1 of the child points to the index of the parent, you like fixing the bug, take care. Thank you, thank you. I appreciate that. I will. Okay, so we validated if it's a child, so we want to just set a boolean for if it's a valid child, if it has a valid child. So we only want to look for another child if there wasn't a valid child. If valid child, then CF Okay. Okay, let's give that a shot. Okay, so what I did here is now when we find a parent that we are going to replace, we check if it has a valid child that we can use to assign a child in terms of having a lower LOD level. So if it can't, then we actually look for the child, right? But if we do find a valid child, then we have no need to go on anymore. Okay. 1, 2, 3, 4, 5, 6, 7. Huh, weird that we're at 7 and not 8. Now we're at 8. Okay, so the logic is probably still messed up. Alright, so let's make sure that we haven't omitted this chunk already. That's a good thing to check. Maybe get rid of the is child flag. We should also check that that um we need to check if this is free. We need to make sure that this is not free, because if this is free, then that means that it can't have a valid child. That's also true. So when it's a valid child, then CF gets set to this ID 0. So that's what we use down here. And we assert that it's greater than or equal to 0, so I'm going to assume that this is working. Maybe we shouldn't even validate that it's ID1 is there. Maybe we should just like keep this make it should be a valid child no matter what, as long as the parent isn't free. If not, then our whole thing is broken. So seems more stable now, but still it does take a while to stabilize. There are still holes. There are really no holes at LOD 0 though now, which is kind of what I care about more so. I think we're getting somewhere though. I think I get the shape of the issue now, but let's try counting. It's hard to count though, because when you move the camera it obviously regenerates. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That should be the correct number. Maybe this isn't the issue. We're definitely out of chunks, right? So we can go into types and we can prove that this is exactly 16. So that's the number that I just counted to. So we are out of chunks. That's what I'm trying to prove there, is that we're out of chunks, and so that's what's happening, right? The thing is, I don't understand why we don't go down an LOD level to LOD 3. Like, this LOD++ should keep going. But we do found K here. And not valid child. See, we aren't doing any. There's none that are getting emitted. Maybe I should check. Okay, so here's what I'm gonna do. I'm going to check the jobs at LOD1. Let's check the jobs at LOD1. That'll give us some insight, because that'll tell me straight up if the ones that are white it out if they're getting into the loop, into the job loop, and just getting rejected somehow. Yeah, this definitely feels better. Trying to find at LOD, yeah, so here. So we have a lot of things happening here. We have too much. Okay, well, let's just exit out. So our cam was at negative 40. So this one's right in front of us with a score of 20, which is very high. So let's follow that job then. Let's follow that job and try and see. So it's definitely getting rejected, right? So that's definitely the one that's right in front of us, right? That obviously has data inside of it. It's a job. It should be getting through. Hopefully it doesn't get zeroed out. We can check that it doesn't get zeroed out too. Let's go based on the original job data j.lod level equals 1. God, I messed that up. My bad. So let's just see if it gets canceled by the zero list, and then if so, then we know it's that, and it's not this. But I have a feeling that it's this. I want to make sure. Okay, so now we'll do and we want to make sure that it's a brand new chunk and not a replacement index, because that's the replacements. And now what I want to do is I want to print out all of the frees at LOD level 1, and then we can directly compare back and forth what the issue is. I'm not going to do vertex counts. Just like that. Oh, the music has been super low, sorry. Sorry about that. I don't know, I've always sucked at accents. Like, they used to make fun of me when I try to do accents. Like, can I be a part of the club even if I do it bad? 0 AI use? Not. I mean, like in terms of me like having an agent or whatever, like I don't have an agent, no. Fuck no. But, I mean, have I asked AI some questions? Absolutely, because like sometimes it's really hard to get resources. Okay, so this definitely is going to tell us something, I think. Because yeah, that chunk is obviously supposed to. But for help as an assistant? Yeah, I guess. I mean, like, have I asked ChatGPT, like, hey, what are the steps that I need to take, like for when I implemented FFTs on the GPU for the first time. Like, yeah, absolutely I did. But yeah. Okay, so there is a slot, and there is a job with a higher priority than that slot. Actually, is that a duplicate? No, it's not. There are 2 jobs with the same that should be getting through here, but they don't get through, even though they have higher priority than these on the free list. Our camera was at 0, -2040, 0, -40, 0, 0, -40. So that's really close to us. And yeah, this could have taken any of these out. This 20.9. Both of these should have. And they didn't. Oh! They got on the 0 list. They were on the 0 list. This is where we printed this out. So that's they got 0 listed out. But they are at -40 and 40, so they are above the ground actually. So that actually probably makes sense, huh? I'm looking for anything else that is at 0Z, because 0Z is what would be within the bounds. Here is one. Oh wait, was that what we... No, that's a free list. Okay, so we don't actually see it. We don't actually see it. Well, we see this. 60-20. This might have actually been it. And then it gets hit with the 0 list, actually. Even though it's a 0Z. Yeah, that can't be right. That cannot be right. Am I a nerd? I guess? I haven't lived the most nerdy life. Kind of, you know, went around and did a bunch of unsavory things, so I don't really consider myself a nerd, per se. But when I was in high school, I was a nerd. You know, and then after that, I wasn't a nerd. But now I guess I'm a nerd again. I do spend all my time fucking writing code, so I think maybe I count. Yeah, I do see those 2 at 0, which they should not be on the 0 list. If they have 0Z, they should not be on the 0 list. They still wouldn't actually be replacing any of this, though. Except these. These are probably -99. That's why they're on the bottom of the free list. Oh wait, no. These would be the first to be replaced. Okay. Why would this be happening? Okay, let's try without the 0 list again. Let's try without the 0 list again, and then just like do the printouts again and see if we get through. I'm trying to build an Arch64 kernel. Want to check it out? Yeah. Send it in the Discord. I always read the code bases that get put in the Discord. Always. So yeah, I'd love to read it. Gonna head out and have a great stream. Thank you. Yeah, DM me anytime. I'll send you that code. It isn't the cleanest code, but I hope that it'll be helpful. So obviously there is still that, but there is still like the flickering that happens. Wish I could slow it down. It seems like the blue is still, it's the blue. It's when blue goes up a level. That's what I'm trying to fix. Or wait, no. No, it's not just blue. Yeah, that red. So the zero list is a big problem for us, I think still, but even without the zero list being a problem, this is still a massive issue with the flashing colors. It means that we're freeing something that we're not meant to free, basically. Also send on Discord. All right, yeah, I'll check it out. Thanks. Yeah, I like reading all the code that people post, and I obviously like reading C code. But yeah, I'll check it out. Thanks. That's awesome. Yeah, I've always wanted to, build a kernel or an OS or something like that. I think that would be a lot of fun. I don't know. I just like doing the graphic stuff is such a drug for me though. Like seeing the visual sort of feedback of it is just really cool. But yeah, I have been reading a lot of literature on OS development and stuff, so I have to one day. Yeah, we're freeing something that we shouldn't, I think. Really, we should not be freeing everything. We should really not be freeing everything. Like, there's no reason for us to free everything. Like, for all the LODK stuff, we should. But we need to be more explicit, I think. Like, we need to free the child of this. But we don't need to actually free it. Because it's going to be replaced anyway. So, just follow the logic instead of just freeing everything just to free it. I think it's probably good. Want to learn graphics as well? It seems too difficult. It's really not. It's really not. To be honest, graphics is hard the first time because there's a lot of linear algebra. But honestly, nowadays, I have my engine code base, right? Like, my game engine. And every time I need to figure out how to do some math or whatever, I have it all written down so that I never actually have to do it again. So that's kind of once you do a project with it, then it gets a lot easier. No, it still is. See that flash, yeah. I think that flash is necessary actually no matter what, because we are replacing it with we are replacing it at the same frame we free it. We free it because something has greater priority, but then we don't replace it in the same frame. And that's what this was supposed to be doing. That's what this was supposed to be doing. So that we don't free things that aren't. Where can I start? For graphics programming, I say just like start something 2D just to like learn an API if you want to learn an API. You don't have to learn an API if you want to like do software rasterization. That's also completely a thing. I'd recommend, you know, either OpenGL or Vulkan or, you know, DirectX. There's really no perfect answer, but just learn how to create a window and do something in 2D, like a triangle or whatever. That's kind of where everybody starts. And then from there, just like start doing 3D. If that's what you want to do. Yeah, I'd say 3D is kind of the way to go. That's where all the fun's at. And then in terms of like getting started doing something in 3D, you're gonna have to look stuff up. Like, you know, how do I draw, you know, a cube or whatever, you know? You just basically create the vertices of a cube. You learn how to upload it to the GPU, and then you learn how to create a shader to draw it. You know, that's like the first step. And then from there, you can draw anything you want, you know?
Tide-free and gentle advanced care goes a layer deeper to remove beyond just surface level.
But yeah, it's just kind of those first steps that, you know, take a while, I think. So this is like 100% so much better already. But I think that it's actually endemic to the system that it will flash eventually. It will flash eventually. Because we're replacing chunks and not making them go to lower LOD levels in the same frame. So if we replace a chunk and it is visible, we need some way to deal with that. Maybe we just simply don't replace chunks that are visible. Maybe we just don't put them on the free list. Is that crazy? If within Frustum, continue? Just that simple? I mean, that's gonna make things a lot harder now, but maybe that's just what I need to do. If it's within Frustum, just like don't touch it in terms of freeing it. Don't free it. Or we set a flag for it to be within Frustum and then we only can replace it and not... I don't know. Yeah, obviously we ended up with some holes. But no more flashing anymore, which is what I expected. But yeah, those holes are kind of brutal. The reason why that's happening is because we don't have a zero list anymore, and we're not checking for zeroed out chunks. Okay, we may have solved the bug. It just needed kind of some rethinking, I think. My family and I watched School Ties the other night. With Brendan Fraser. He was really good in it. I think I hate Matt Damon. I think that's what I learned. I think he's really bad at acting. I mean, not to be like, you know, an asshole or whatever, but I just don't think he's very good. Anyway, yeah, the zero list seems to be complete ass. Yeah, the zero list just... Yeah, I gotta figure out the overheating problem. Like, we're overheating right now because of... I think it's my lighting logic, but I need to figure out... Maybe I need to do like a lookup table for it. I think that might be what I have to do. I'll have to look into it later, I think. Honestly, I could just do an EXPF lookup table. It's not like the craziest thing. Trying to see under what circumstances. Yeah, this completely makes sense here. Yeah, I don't know. Let's try getting rid of this, I guess. I mean, I doubt that has anything to do with it. Maybe it was this, me getting rid of the replacement negative ones here. I don't know. We have a fence here just in case, but maybe we just free both parents and children here. No, you have to free the child. On the GPU, what's the layout here? I go LOD times max chunks, right? Yeah. Yeah, absolutely. Max chunks is 100% the same. Yeah, the strange thing is that obviously like 90% of the time the zero list works. However, sometimes obviously it doesn't work. Oh wow. Wait, is this just working now? What the fuck? Okay. Alright. Okay. Okay, well it just works now, so I can't really complain. Can't really complain. Unfortunately, the fact that this does work means that we do have to upload -1s to the GPU every frame, which is really not what you want to see, to be honest. I guess that the bugs started happening when I commented that out, and I just didn't really notice, but you know, that is what it is, I guess. Is what it is, I guess. Yeah, so let's just like 100% guarantee it here. %100% lock in the bug here. It's cool that you can profile with RenderDoc. I only kind of debugged with it before. Also, it looks like they've changed it a bunch, actually, which is cool. That was cool. Maybe I'll use it more. I don't know. Yeah, this is 100% the bug. Yeah. Yeah. Yeah, doing that GL buffer sub data is actually disgusting, having to do that, which is unfortunate. I don't think that, RenderDoc can actually profile that, can it? I'm on the Intel GPU, so I can't actually what was I saying? I can't actually profile it. On the NVIDIA GPU I can though, so that's what I'm gonna do now. Let's do the whole render thing. And then, let's do mesh. Let's do the mesh. Collision doesn't matter. Okay, so just set up the timers. I want to go into here and make sure that we aren't querying over it. Okay, so let's see how we're at. Let's go to the NVIDIA GPU just to do the test. Yeah, I've been working on my CV. Some, you know, job hunting or whatever. It's kind of hard. I don't have professional experience. I just have done a lot of projects. So, I don't know. That's where AI has been helping me, is like trying to... Oh wow, this is so fast on the NVIDIA GPU. Holy shit. Jesus. This thing runs so fast. Is this like 500 FPS or something? Jesus. Wow. I think like my code is so slow until I run it on the actual GPU. This is a 1050 by the way. Okay, let's see what we got. So mesh is 5. Yeah. Mesh is 5, which is really not what you want to see. Really not what you want to see. Let's see if it's 5 every time. 5, 5, 5. Yeah, 5. Yeah. Ooh, that's rough. I mean, you know, like, I could technically, just do one dispatch at the beginning to clear everything to -1. I don't know how fast that would be, rather than doing this. Let's actually do the test. Let's test how expensive that is. Yeah, that's where AI has been helping me in doing the job stuff, because I suck at doing that, and I suck at writing like descriptions for the work that I've done. Like I suck at like the wording and making it sound cool or whatever. I also have like internal kind of problems with like, I just like kind of put myself down about the work that I've done, I guess. I mean, to me it doesn't seem like impressive when I see the work that other people have done, I guess. That's kind of my problem with it. Oh wow, it's 5 regardless. Wow, it's 5 regardless. Am I sure that this is profiling the right thing? I feel like it might not be. It apparently is. I don't have frame, which is the problem, but it apparently is. Maybe it's this fence that's actually killing us. Or maybe it is the map buffer range. Let's see if it's the fence, and then we'll go for the map buffer range. Also, while we're profiling, we should not be printing out all of this debug information anymore. Yeah, it's also... Hey Enigma, what's up? It's also like I suck at putting my code on GitHub because like I like for it to be very clean and perfect before I put it up. Like I'll spend like a couple of days when I get to a good stopping point with a project where I will, like for the Lenia thing, I literally spent like a day just doing that. And I think I should do something close to that here. So let's see what the profiling says. 3, 4. This is still 4. It's been going good. It's been going alright. I'm just fixing some bugs. I fixed the bugs, but now I'm trying to figure out why we're so slow. And I think it's reading this buffer back to the CPU. That's why we're slow. Tracking system looks nice, thanks. That's the version with the bugs in it. It's actually kind of perfect now, but yeah, it's been good. I think I've been so happy about the water. I don't know if you've seen the water, but I think the water is sick. It is expensive. Oh. Well. Now everything is on the free list because of the thing. And yeah, so the mesh is 0. Well, you have to fill it with -1. You have to mem set new list, -1 size of new list, just so that we can test. I'm just trying to test how expensive this map buffer range is. It's apparently 5 milliseconds, which is a lot. 5 milliseconds is a lot. So this one call to the GPU is 5 milliseconds, which is insane. Because it's blocking. It's a blocking call that reads back, so thanks. Thank you. It's cool when it's at night. I'll show you when it's at night. So the reflections on the water get kind of nice. Very picturesque. So yeah. Yep. Mesh is 0 without that call. Oh my gosh. The pads are coming off my glasses, but the problem is I don't have replacement pads here yet. So that's unfortunate. I have to wait a couple of days, so I'm gonna have a couple of days where my glasses are sliding off of my face, which is not good. So this map buffer range is that expensive. It's 5 milliseconds. So I have no clue what to do about that. No clue. There's no real good solution. I thought about this unsynchronized bit. I tried this before, but then this just doesn't work. Maybe it works on NVIDIA, but not Intel. Yeah, this just gave me a black screen the last time I tried it. Exposes the repeatness, yeah. Yeah. I mean, yeah. It's the reason why it's so expensive is because it blocks the GPU. So, there's not much I can do about it other than maybe moving the logic to the GPU entirely. But that's an insane refactor. Also, it would be very difficult. Yeah, seg faults, that's what I thought. I think you have to make the buffer with that flag for it. Yeah, I'm not sure. Let me look this up. Oh my god, my glasses are gonna be falling off my face the entire time. This is like so bad, actually. I might have to like make something to hold them onto my face. GL pixel pack buffer. Yeah, I have no clue. I don't think that there's an easy way to do it. Yeah, it's not the water that's the call. It's the chunking system. The call that's expensive is the buffer that tells us which chunks are empty and which are not. That's the expensive part. Which is necessary because we need to know which are empty so that we can replace them. Yeah, that's not gonna work, buddy. Okay, yeah, I might have to take the other one off so that we can actually move forward here. Oh, that's unfortunate. God, this sucks. You know, I got these glasses, you know, and I got them at this place, right? And they were like, "Oh yeah, sure. Like, we'll put them closer to your nose so that it fits." And then I went there, and then they put it in like one of those heating things, and then like moved the plastic or whatever, and then I was like, oh, it's still not good, I need it more. And then they did it again, and then I was like, oh, it's still not more. And then she like gave like an eye roll and then did it again, and it still wasn't good enough. And then I was like, okay, well, thank you. And then that was it. I saw your side in DS, and it clenched my own confusion of your confusion. Yeah, you got it then. Yeah, it's yeah, I read that. I had just woken up and I read that on my phone, and I looked at that for loop and I was like, why does the for loop seem quite perplexing to me? Because that looked like a type in the for loop. It looked like this was like uint64t. Like, that's what it looked like for me, because I didn't really know that that was a I typed up or you know, that was the size of something. So that definitely confused me. But yeah. Also not really how I'd write something. I very typically avoid underflowing or overflowing all the time. Unless I'm bit shifting. If I'm bit shifting, then underflowing or overflowing is 100% like fine, but I don't know. I've had some weird things happen with it. So yeah, I don't know. Apparently when you create it, you can create it in... You can create the SSBO with a different flag. Like, you can create it GL buffer data, GL storage buffer. You can do GL storage buffer storage. And then you can do bit field flags at the end. But I had some problems with this beforehand. Let me look this up. Oh, come on, man. Dude, like... Please. Basically, it just creates a register. I see, but for that, it wasn't really clear based on your starting value for the for loop was you didn't really start it at the top of the range, right? So it was kind of not 100% interesting, or you know, I'd have to look at the code again, but yeah, it was confusing. Yeah, that I understand that now. I understand that now, but it was kind of confusing to see it written that way. This is what we want, but I don't know if it works. GL map read bit. GL dynamic storage bit, GL map read bit. Okay, I don't really know. I don't really know. Now basically you just map it once.
That's the sound of a warm
and then that works
vacation
fine.
with credit card points. Ooh, and
We could just do it once, or map it once apparently, and now it's persistent. I have no clue how this works though. The last time I tried to do this, it didn't work. So we're just gonna try it and see if it works. We need to have a global thing. Yeah, a global thing. Okay, so we're just gonna map it right away. Just map it right away to here. I see. I see. Jill read, Jill persistent. Yeah, this GL map and synchronized bit indicates that GL should not attempt to synchronize pending operations. No GL is which sorts or modify. Yeah, this I tried this and then we instantly crash every time. So okay, so that's fine. I see. Yeah, that makes sense. That makes sense. I just yeah, I just didn't really get it at the time, to be honest. I'm kind of also just not the best at reading code in general. But yeah. Okay, so we mapped the buffer. Alright, so now we, instead of mapping it out, we just refer into the right now let's just do data pointer read flag. Alright, let's give it a shot. Last time I got some undefined behavior from this. Why is the music stopping? Oh.
User spiked overnight, but your stress level didn't.
Okay, we're actually running,
Keeps performing steady. So
and it's correct.
you don't break a sweat.
And we are still at 5. We're actually at 6 now.
It's Gumbo, and this time I got to help out. Grandma says that the roux is the heart of the gumbo. I was stirring it forever. Dad even let me.
What? How is it still 5? Hey, what's up, Max? I see. Yeah, I mean, like, fuck if I know. At this point, I'm starting to think that it's... Okay, so now the... Okay, so now... Okay, got it. Got it. So now it's the upload. Now it's the upload, that's the problem. If we have persistent bit, can I just set this straight into the pointer? Let's check it out. Do I have to put this in parentheses? No. Alright, that's fine. Let's try it. Oh, also we should not be unmapping the buffer, duh. Gotta wake up early for a trip. Where are you going? Where are you going? Where are you going? Okay, you don't have to tell me where you're going. Because that's like, you know, that's personal information, but I'm just asking in general, you know. What is the purpose of the trip? Are you taking a vacation? Oh shit. Oh shit. Persistent buffers, man. Persistent buffers are the shit. Persistent buffers, man, that's the shit right there. Nice. 0.04 seconds. 0.004 seconds. Now that's efficiency. On the NVIDIA GPU, we're well underneath the amount of time. And we have fixed the bug with the chunking system, so yeah, I think that's a win. This is a big win for us. A big win for us. Where am I not going? Would have been a better question. Why is that's so mysterious? Where am I? Are you going everywhere? Damn. That's crazy. I didn't really know that you could go everywhere all at once. You're going pretty much in half of the country in 3 days. Damn. Really? That's pretty fast. That's pretty intense. Are you just like driving around? Or what? Maybe you are just driving around. Maybe you're just driving around. I want to run this on not the NVIDIA GPU and then see how we're doing. I like Schrodinger's cat. Superposition. Interesting. You know, object dump existed? No. It will pretty much boil down to driving around. Well, that's cool. Are you going to any place specifically, or you're just like going on a road trip for a few days? So decided I'm gonna get out of Dodge, and now you're just out of Dodge.
Are you ready to restore paradise?
Yeah, we are a bit slow on the NVIDIA GPU, or on the shitty Intel GPU. Not gonna lie. But this looks, I mean, this looks golden. We're golden right now. We're a golden child. You know, I wouldn't mind ads if they weren't shit. Like, shut up. It's like, I don't know, like, make better ads and then I won't be annoyed by them. Very simple. Alright, yeah, it looks good. Yeah, see 23. Collision. Why is collision high? Oh wait, these timers are working now. Oh shit. The timers are working. Why is collision 11? So. That can't be right. There has to be something else going on there. I turned off collision timing beforehand for a while. There's no way that it's actually taking that much time. Oh, it's because we never end the frame timer, probably. Oh no, we do. So really that crazy? 4? Should not be 4. I've always just made the... I see. Alright, peace out, Max. Alright, nice, nice. Yeah, collision being 6 is pretty... I mean, I don't think that you know everything. More than me about certain things for sure. Huh. Yeah, collision being 4 milliseconds has to come down. That's way too big. We should prove that it is collision by flying instead. Okay, so let's see if collision is still just to prove it. Yeah, okay. Okay. Also, we still are printing out all of this, which I didn't mean to leave in. So let's get rid of all of that. Creating new mesh is fine, we can keep that in. This is not necessary. Those are all necessary. Okay. We can clean that up later, but that's that for now. It's expensive, but it's within reason for now. Collision is not within reason. Collision needs to come down. Next. So let's get working on it. Yeah, he would just do the resolution, but I'm assuming that So we find surface once, and then we check collision, hit ground, find surface entry. So it's just one find surface entry and one one call to find ground. Or find surface Z, maybe? No, it's not. It's what was it called? I gotta get rid of all this shit. Find surface. Alright, so this one's the tough one actually, because this one's the
With spring deals at Ashley, you can
two other individuals. You can say guys. I mean, we just kind of like looked at it and it's a bit confusing, right? Like, you had a second function that you were going into with, you know, a const array of 3 elements that were 0, 1, and 2. You know, it just looked like a very strange kind of, you know, whatever you were doing there was kind of strange. But perhaps, you know, you just wrote it to make a point or whatever. But yeah, it's strange for sure to read it. So this is a step size of 0.001 and a fail of 1000. And we can't bring that to 1, really? Let's just try it. Yeah, I mean, I get it. I get it, you know, but I think that there was like a much, you know, less convoluted way to say that, hey, this is a pointer to a stack allocated buffer that's gonna go out of scope. You know what I mean? Like, it's just a very, you know, complicated way of writing it. But yeah. It's definitely more bumpy now, but let's just see. Okay, we came down to 2 just off of that, so that's definitely really good. Question becomes, what's that? I mean, you could just, you know, it's just not. There's definitely a much easier, more like simple way of writing it that, you know, to illustrate that point, you know. But yeah, I mean, I don't know. You could just preface it by saying that brackets are scopes, and when something exits the scope, then there's no guarantee that it's still going to exist, even if you have an underlying pointer, you know. So there's other ways of you know, definitely saying that, but you know. The question is, what's a scope? Well, I just explained what a scope was. You know what I mean? Like, I just explained, right, that you can scope something basically within brackets, and obviously a function has brackets, so that's a scope, right? So it's a simple way to write it, right? To explain it, you know? But you could also write something, you know, very simple, just like one function, and then the other function just retrieves the function and then not have the loop, right? You know, be fairly simple, right? I don't, you know, if the whole point was to explain what it is, with being simple and explanatory. You could have just written a loop that didn't look like this, you know? Like, this is a relatively confusing sort of layout for a for loop, right? So, you know, if your intention was to explain something to a beginner, it's definitely a more convoluted example than, you know, in my opinion. So this is just dotting. I think, yeah, first of all, let's just totally clean this up at this point. We don't even use this anymore, the bounding box. Let's fork the file. Okay, let's just get rid of literally everything that's in here. It's not necessary. Only get what's necessary. So we just add dir's step. We don't use step length anymore, I don't think. So it's baked into dir's step. Oh no, that's what we use to calculate dir's step, of course. D is the starting density, that's important. Okay, yeah. And the step amount is 100. 100 seems like a good amount. You could also go down to 50, but yeah, I think you just want to stay at 100, and then that's fine. It's a bit ignorant. I mean, I guess, yeah. I mean, it's kind of a hand wavy thing about explaining it, but you know, yeah. Yeah, I mean, it's fine. It's fine. You should just, you know, don't be surprised when other people find it a bit, you know, confusing, right? When, you know, I don't know.
Chaos isn't music to anybody's ears. Azure brings everything into one clean.
It's not exactly, you know, the way I'd think of it, you know.
Cat food?
Yeah, that's, I get that completely. Okay, we just have to clean this up a lot. I've got a lot of stuff that we need to clean up here. I guess my idea was to eventually put the collision on the GPU, but I don't see that there's any point now. Collision still doesn't work when the frequency is too high of the geometry, which is a problem because we don't actually resolve against the ground, but we only do the density field, so it's kind of whatever. Well, I kind of got everything I wanted to do done today, so that's good. Before I forget, I want to get rid of this. It just literally loops to count times. I mean, yeah, but you didn't write to count, right? Like, you realized that you looped to your internal type def for some value, right? So you could have just written, you know, any value, right, and gotten the same point across, right? But you know, it's just kind of writing to something called U64 doesn't really tell you that you're looping through all of the values of a U64, or you know what you're actually doing, right? So it's just kind of, it is confusing. It's a confusing way to write a loop, especially, you know, it is fairly confusing, right? If you're not looping through all the values of a U64, then like what is that, you know, value doing, you know? That's confusing to me. I don't know. Maybe I'm just too dumb to understand it, but yeah, that was fairly confusing to me. But maybe I'd have to look at the code again, but you know, I don't think that I'm exactly, you know, wrong to be confused about it in some sense. Like, it's not like the most obvious code, personally, you know. Where do I even get that? Where do I get that? Because I don't know your code base. Like that's where I don't get that, right? To me, that looks like I like looping to you know, int max or something like this, right? Like that's what that's what I took that to mean, right? So, you know, that's when I read it, right? When I saw, you know, what I assumed your type was there. So I was like, okay, you're looping through all the values of a uint64 and you're underflowing to do some purpose, right? You know, it doesn't really make sense to me, you know, just from reading your code base with your types, right? It's not exactly like the most obvious thing of all time, you know. But yeah. Okay, we don't need these timers anymore. Okay. Okay.
affordable German-engineered car brand is also the most fun. Get in the driver's seat today.
Yeah, see, that's the strange part, right? Is the cast to the -1, right? It looks like int max -1. Like, it looks like int max -1. That's what it looks like to me, without knowing your type, right? You know, that's what it looked like to me, right? And it wasn't just me that thought that, right? It was also Wyland that thought that, you know. But I mean, you've got to see that there's kind of the reason why we both thought that you were doing some underflowing arithmetic, you know. But yeah. Yeah, I think honestly I got everything done that I wanted to do today. I fixed the chunking bug finally, and I profiled the water. I don't know, man. Maybe I should work on a lookup table for EXP, I guess. I just don't know what value what value range I'm supposed to be making a lookup table for. Like, here this exp, right? Negative depth diff times absorption coefficient. I'm guessing that this depth diff can go up to 1000. Times 0.2. So we would have to make a lookup table texture that goes from a negative 200 to 0 and then just index into it. That shouldn't be that tough to do. It's kind of a pain in the ass, but let's just give it a shot. Let's just give it a shot. Also, I need to chill it, so I'm gonna play this. I'm going to play this now. Yeah, I mean, I get it now, right? Like, I've had to cast, you know, to a certain type plenty of times, just, you know, just because it's necessary. But, you know, it is kind of, you know, without knowing your types, right? It's kind of like difficult to know that, right? But yeah. Yeah. Yeah, so if I want to make a lookup table, either a texture or I think I want to do a texture and just like linear interpolate it. Then I'll make a texture here. It's gonna take up VRAM, but it should be fine. I want to make it it's gonna be called exp lookup. We could probably use this for other exp calculations that aren't just that, but I don't know if I should just do a big range or what, but hopefully it's fine. So it's gonna be GL or 32F. GL red. Yeah, exactly. Yeah, it is. I've had to cast annoyingly some things plenty of times when I'm doing bit operations. Like, obviously when you're doing, you know, bit shifts, right, you have to, you know, make sure you put the ULL, so I completely get it, right? Yeah, we just want to clamp to edge. And we can linear it. So let's go and get the exp lookup texture. After this, I might actually just like start loading in some other textures and then seeing how we can interpolate between them. Get like mountains and stuff. That'd be cool. Yeah, that's the main thing that I've had to cast beforehand, is when I'm doing bit stuff, is like you've got to you've always got to cast it so that it knows what you're doing. So we're gonna bind that when we're doing the water calculations. Of course, there's overhead to this, but it should be way faster than doing it otherwise. EXP lookup texture. Yeah, yeah, yeah. So UEXP is going to be what we're calling it. And we will put it here. Oh, this is the wrong shader. And now we just go we're just gonna make it positive, even though we're just gonna put negative values into it so that it's always correct. So now to actually init this texture, we have to create a buffer that's obviously it's going to have a width of 200 with a height of 1. And so we have to respect that here and go, obviously going only by width and not by height. So that's gonna be 0, right? Okay, so now we need to create a buffer for floats. To 200, and now we're just going to for loop through it and pre-compute the lookups for it. We're gonna go exp of I. That's literally it. It literally should be it. Let's just do expf, and that's fine. And now we just want to gl. We can just do it right here and upload exp lookup. And hopefully that works. I think I just kind of blacked out and wrote the code, so let's hope that it makes sense. Oh wait, we're supposed to be going negative I. Oh, we got an error. Absorption redeclared. Whoops. Whoopsie daisy. Okay. Yeah, I'm not sure if this is going to work, but it probably, is like too big of a range maybe for it to, like, maybe, I don't know. I don't know what the values are actually like. I don't know what the values are actually like. Yeah. Yeah. That's what I was worried about. You can technically do 1000 and then just like do I divided by divided by 5. And then just have that be the ratio. And then we just like, this is just the precision now. My code been going? It's going good. I have been working on, I have this expensive thing in this shader, this EXP here that I'm trying to do a lookup table for. So that's why. Obviously we have to divide this by 5 at the end. Yeah. Right? Yeah. Yeah. If you're dividing 1 by 5, then you have to divide the other. How do you feel on how it's organized? I kind of haven't gotten to the point with this project where I want to organize it yet, in terms of like cleaning it up. There's still a lot of stuff that I need to do. I need to relook at the noise and make sure that we can have mountains and stuff and all of that. I need to make some sort of pipeline so that we can load in other textures and interpolate between them. So is it very slightly transparent? Yeah, very, very slightly transparent. Very. Yeah. So it's working. It's just the lack of precision is kind of ridiculous. If we go to 10,000, we need more precision is what I'm realizing. So this would start out at 200, right? So 200 times 5. So times 50. Very opaque water. Yeah, I'm working on the lookup table, but it needs to be higher precision. Heavy water, yeah. Let's just try that. Don't tell me we're seg faulting. Okay, we're fine. Okay, there we go. That's about to where it was. Kind of. It's definitely not as high def as it was before. You know, you lose precision with this for sure. Without a doubt. But now it should be faster, and we can test this by going into Aria's favorite program, RenderDoc. I looked on Aria's computers, and the only thing that was on there was RenderDoc. And it's disgusting. Craziest thing I've ever seen. Alright. Well, better than being blind. I would rather be blind. Shit's lame. Alright, let's see. Let's see what we got. $500 megabytes? Nice. Not bloated at all. Yep, and we're down from 5 to 3. Oh, wait, no. Wait, this is still 5,000. Ew. 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 Oh. Oh. Bro, you can't be fucking serious, dude. You can't be fucking serious. No, you're not for real. You're not for real. You're not for real. You just aren't serious, dude. Like, this texture lookup has to be so cheap. Bro. We can't be for real. Maybe it isn't the texture lookup. Maybe it's, I don't know. Maybe it's sampling the cube map. I don't know. There's a lot. There's a lot that it could be. The cube map is so tiny though. The cube map is 128 by 128 by 128. Is there anything that I could bring in here that... How large is the texture? The lookup texture? It's large. It is large. It is 10K. It's 10K by 1 though, is the thing. So this is 10K by 1. So yeah. We could probably bring it down to 1K, but then we would have to rethink some things. We'd have to clamp differently. Jesus. 10K is not a large. Like, think about a 256 by 256 texture. Its Y being 1 doesn't change anything? I think it does. Well, maybe it doesn't. I don't know. It's just arrays all the way down. Its Y being 1 does change the size of the array. Like, if we're talking about a texture that is 256 by 256, that is way larger. That is loud. That is like a lot of... That is large. It's like... I don't know what you're talking about. 256 by 256 is a standard texture size, you know. So that's would be larger than what I currently have. It's in terms of textures, that's not even that big. If dividing by 50 is what we need in terms of precision, then this needs to come down to 500, the clamp, and that's unfortunate. But yeah, I don't think that us changing the size of the texture is going to do anything, but we can try. Yeah, I understand how multiplication works, right? But 256 times 256. I understand what you're saying completely. I understand what you're saying completely, but like 256 by 256 is massive, right? Like 10,000 times 1 is not like, I don't know what you're trying to get at. Like 250, like I don't know what your point is. I don't get it. I don't get it. I don't get it. I do not get it. I don't get it. Count is fixed. Count is fixed to 10,000. It's fixed to 10,000, right? But in texture space, 10,000 isn't even that much when we have the screen space is 1920 by 1080 in terms of pixels. Like, do the math on that. Like, what? Doesn't make any sense to me why you think that that's a large number for a texture. It's not. Now, in terms of lookups, will it have an effect? Possibly. It'll possibly have an effect. But, you know, 10,000 is not a large amount at all. Yeah, it's the same, yeah. What the OS is doing under the hood. In terms of a GPU texture lookup, right? The size does have some, you know, something to do with that, but you know, I don't know. It's kind of like what I'm trying to say is that it's a very reasonable thing. It's very reasonable size. I mean, like it doesn't really change anything. The size. What might actually change something is honestly turning this to nearest so that it doesn't do any interpolation. I still doubt it though that matters. I doubt it. Doubt it. I mean, the bigger picture is just that this is in terms of a GPU and not a CPU, right? So texture lookups on a GPU. In terms of the size, yeah, it does matter because it's less like memory traffic, but at the same time, it's not really like, it's not really 100% the thing. Like, what really matters is if there's a lookup at all, or if there isn't a lookup, you know, is sort of the thing. Especially with linear interpolation, you know, because it has to filter. But yeah, 256 times 256 is just simply bigger than it, you know. And 256 by 256 is a very small texture size, right? So the numbers just get large. Now, if there's an argument about if I should be using the other dimension of the texture, maybe, but also we just have low FPS right now, which is concerning. Yeah. 4,000. See, we have 12,000. I wonder if almost it's just like literally the fact that we changed chunk radius that why we're not ahead in performance. I think that that's probably what it is why we're under 60 FPS. And if it is that, then there's really nothing I can do about it, so. Or there is, it's just called use a less bad GPU, but yeah. Yeah, I mean, once you just like write a few, you know, compute traders and stuff, you get like the understanding of what's expensive and what's not, you know. I mean, textual lookups definitely aren't free, especially in a fragment shader, but for the water effect that I want to have, it is sort of necessary. Yeah, it doesn't appear to have fixed it at all. Yeah, it's probably because when we're close up, we don't really have the cost of being on top. Let's actually, out of curiosity, let's try to go back to before we did the lookup just to see what it's like. Just to see. The absorption, yeah. So let's just literally check this out. We don't have to recompile, obviously. Yeah, definitely. I mean, for GPUs, it's definitely like the exact same thing. It's just the cache works very, you know, different from on a CPU. I definitely prefer writing CPU code to GPU code because of that reason. But yeah. Okay, let's see the performance difference if there is one. Yeah, I think that this is faster, actually, without the texture lookup. On the NVIDIA GPU, by the way, we're at 60 FPS, like we're at like 90, you know, 120 plus, really. Like we get done with everything so fast on the NVIDIA GPU, but this is rough. It's actually, the interesting thing is that this is only 10, so the rest of it's actually CPU side during frame. CPU side during frame. Maybe it's uploading the UBO and stuff. The FFT time, I'm looking at the time on my other monitor. Yeah, it looks like collision is 0, mesh is 2, and then frame was 6. And frame is just what's in here on the CPU. Frame is inside of here. We wait till the end of the menu as well, but I'm gonna guess that it's CPU side inside of here. That there's something that's expensive. We also are looking up uniform locations, which isn't great. I didn't optimize that yet. This clear color call is also pretty expensive, I think. I don't really know the exact... the reason why we have to clear color to 1 is because of the way we do depth. So there's that. I wonder if this is actually the CPU cost, is all of this shit. It might be. Let's only draw LED 0 and then see if that cost goes down. I just want to see the raw, because frame is expensive now, and that frame timer is on the CPU, not the GPU. Memory bandwidth. There's a lot that can cause bottlenecks, mainly the fact that GPUs are inherently so unthread safe that most of the job that programmers do is slowing them down. We have to slow them down. Frame is 2 now. From 3, 2, 2, 2, 2, 2, 2. Oh, I meant to do this, obviously. Oh my god, I didn't recompile. That's so ironic. Yeah, I mean, most of what we have to do when you're doing GPU programming is you have to put barriers everywhere. Because all the threads have to sync up all the time. Because they're so fast and unthread safe that it's very, very hard to sync them. In fact, in compute shaders, there's really no way to sync all of the GPU threads. So you have individual work groups that can communicate with themselves, right? And so you have to build around the fact that there are so many threads and the fact that all of them are somewhat, thread unsafe. So it's difficult. Glad I got the bug done. That was nice. Okay, so let's see. Frame is still 5. 5, 5, 5, 4, 3, 3, 5. So I guess it's not that, because it's still very large. Huh. We don't need to clear the depth buffer bit there. Or for this, we don't have to clear the depth buffer bit, so that's good. And for post-process shader, we don't have to obviously write the depth buffer at all. So that's obviously that. It's fine. Yeah, it might be. I don't know. Yeah, I'm gonna have to take a look at it more later. Yeah. Yeah. Frame didn't used to be 5, I think. I wonder what that time is coming from. We can do some timers in here to see. We can take the FFT timer and then just put it down here, and then we'll see. Let's go just before the water. Oh, I need to get the... So obviously it's not going to be FFT time, but I need to know. Uh, well, I guess we do need depth buffer bit there. I'll just keep that for now. Isn't it more accurate to call GPU threads just cores? I guess. Possibly. I guess it just makes more sense to call them threads and the idea of execution. I don't know, everybody calls them threads, so I think there's got to be a reason for, I don't know what the difference between a thread and a core is really in terms of that, but okay. Frame is 5, so that's and FFT time is 0.7. 0.77. Okay. Seeing as there's a layer of abstraction from the OS. Yeah. Yeah. I would think that it's not really a core if it's not on the CPU. I don't know. Where is it? Oh, it's here. Really? Oh, I didn't actually move the goddamn timer. God damn it. I fucked it up. Alright, I know today was kind of boring. I didn't really do anything that exciting today, but I'm gonna peace out here soon, get some dinner. ALU then? Yeah, I guess so. I guess so. I mean, I don't know. There's apparently like hyper threading or something. So that's like apparently the reason why you can do a lot of threads with just a certain amount of cores. I don't really know what that's about though, but apparently it's independent. .5. Okay, well now I'm really confused. Well, you know what? Maybe we weren't supposed to figure it out. Because if you go after here, then now it's just the entire thing, by the way. That's just the entire fucking thing. So. I guess, I mean, I didn't really do the water stuff live today, other than, you know, try and optimize it better. The main thing I did today was the chunk thing, so. Yeah, FFT time is not going to tell me anything. So maybe the frame thing is just BS. Or maybe it's actually the... Like, how stupid would it be if that's the UI? Actually, it might be. It actually might be the UI. It might be nuclear that's tanking the performance. How cursed would that be? That would piss me off. Oh, it might actually be. Oh, yeah, that would make sense. Shit. Yeah, that would make a lot of sense. Yeah, I like it too. It's a shame that it's expensive though, to get it looking this good. It doesn't work well on this GPU, which is Intel UHD 620. So it's a shame that we're capped by it, but that is what it is. Yep, that's what it was. That's what it was. Now we're down 4. We're down 4 milliseconds from that. Alright, let's put it in render doc and see. Quick question you got? Sure, shoot it. Shoot it at me. Maybe menus are just expensive and that's fine. I don't know. Some marching cubes modifiable? Why? There's only one value you would really change, and that's ISO value. So there's nothing to really change per se, other than ISO value up or ISO value down. And ISO value needs to be exactly 0 for the collision to work. So seeing as that is the case, it can't really be modified, unfortunately. What was our FPS? I wasn't paying attention to the FPS. Oh my god. I wasn't paying attention to the FPS. Bozo. I don't think I can see the FPS here. I probably can. I'm too stupid. So it's not 3D? Yeah, it's 3D. But there's the only thing that you can modify within marching cubes is ISO value. Yes, it's 3D. Yeah. It is a 3D volume that it marches through. If it's a mapping, I'm not sure. That's not really marching cubes' thing at all. Yeah, so we're not at 60 FPS still, or 41. Yeah, I have to play around with it more to get us to 60 again. The only real thing that is really going on in marching cubes is the ISO value. That's the only thing you can really change. The rest is just vertices and edges with pre-computed lookup tables. ISO is density. Not necessarily. It's the number that determines your edge configurations. When you're iterating through it, you're comparing against the ISO value from the density field to determine if that is going to have an edge or not. So it technically is density, but it sometimes works out that the mesh is denser where the ISO value was negated still. Hence the stuff within my Linear project. So yeah, bummer that the FPS is so fucked up, but yeah. Not much I can do. Yeah, basically density, yeah. Not that much I can do about it from here. I have to keep thinking about it. The thing is that this frame says 9. So in my math, 9 milliseconds should be very fast, but we're not fast. So I have no clue. I have literally no clue why. If the drawing goes fast, and we can also see here that the collision says, oh no. The collision says that it's 4, 7. Oh, hold on. Is this using an old version of the executable? No, because this one didn't have the. Huh. I don't know why collision looks to be so high here. But that still doesn't add up. It's 4, 4, 2, 9. So 9 plus 4. Nah, that's 5. Okay, so. Yeah, I mean, yeah, I guess. Really, the collision is still that high. Am I sure about that? Like, really? But that should make it modifiable? No, because all of our collision works straight off of the density field that builds the meshes. So everything is based on 0 being ground. All of the collision logic depends on that. So there's no raycasting involved in this, no. .43 FPS. I don't understand why we're late to the swap when frame is 10 or 11 milliseconds and the rest of our logic is 5. Why are we at 20? Why are we late to the swap? That doesn't make any sense. I don't know, maybe the... Maybe the query result is slowing us down or something. Like I don't know. That's what I was gonna try next. But I mean, where you look at if such would be implemented. Yeah, I mean, the thing is that it's all based off of the density field, right? So as long as 0 is where it changes from negative to positive, right, then all of the logic works, right? And so for that, ISO value needs to be 0. So for that to work. Why does that not, what? Why do the chunks not fucking work here? What the fuck did I do? Couldn't find hashcam chunk. Huh. Okay. Weird. Definitely weird. Weird. Yeah, I mean, it's also like not necessary because you can change the noise to such a degree where the density can be already shaped in that manner that you're asking about, right? Like there's not really a point in it. Like if I brought back the UI, you would see the ability to just simply change the terrain completely. Yeah, I don't know why this isn't actually showing the terrain anymore. That's kind of fucking... No, it has nothing to do with LOD. No, it has nothing to do with LOD. It would just be that our collision would not work. Our collision would... depends on the boundary between +1 and -1 being the ground. Once you change the ISO value, there is no guarantee on that at all, right? And so you can't create collision from the density field, right? I would have to start calculating collision from the mesh itself, which would be incredibly expensive, right? It's not like for my lack of trying, right? It just would not be, there would be no point to it, right? There's no point because I can change the geometry as I like with just noise itself. I don't need to change the ISO value, right? So that's how I think about it. But yeah. Yeah, I don't know why the fucking ground is going away now. It's very confusing and worrying. Yeah, I have no clue why. Is that me changing the chunk radius? Fucked it up that bad. Okay, so let's see. Okay, so we are at 59 FPS. Sir. 56. 59. Okay. So what I got rid of was us querying this result was blocking us completely. Now I've got to figure out why we aren't doing chunks anymore though. Like why did this break that? What did I change? What did I change? Depth. Did UXP. So this was what was halting us, was this. So we don't even have to worry about anything anymore. There. Margin cubes is even implemented. You're basically just going through the density field, checking your density at all 8 corners of a cube, and then you look up a configuration of vertices based on those 8 points, and if they pass the ISO value test, and then the rest of it is just interpolating those points. Yeah, so I fucked something up here with the actual terrain. Is it just broken and I didn't realize? No, right? That just happened. Huh. Huh. Yeah, it's not well, but yeah, I fucked something up. Anyway, what you can do here is that you can change all of these values, right? And so it'll change the fields anyway. Like, I don't really have it at very fine amounts right now, but you can basically shape the field to what you want anyway. It doesn't really need anything else. Oh, nah. Yeah, that's funny. But yeah, I was just showing off that you can change things here to make it you know, different, right? That there's no yeah. I gotta figure out why the chunking system all of a sudden doesn't work. Like, I just spent so long fixing it, and now all of a sudden it isn't working. Maybe it's the persistent buffer. Oh. Oh, shit. Oh, I think I just realized something. I think that it never worked on Intel, but it works on... I think it works on NVIDIA, but it doesn't work on Intel, what I'm doing with the persistent bit map buffer. Fuck, man. Yeah. That's why we are under... Yeah. Yep. Works on NVIDIA. It works on NVIDIA, but not on Intel. Yeah. That fucking sucks. That sucks so bad. That just ruined my whole fucking day. Dude, are you serious? Alright, well, I'm gonna have to come up with something to deal with this on Intel. So that sucks. Yeah. That sucks. I can't have a persistent buffer like this on Intel. Let me see if I can at least do this on Intel. It's not really architectures, it's just I have 2 GPUs in this laptop, and one of them is so archaic and shit that it doesn't support anything relatively modern for, you know, for the past like 5-6 years in terms of graphics programming. So anything to do with SSBOs beyond just, you know, just having them is, yeah, this doesn't even work. Yeah, Yep. Yeah, you can't have a persistent buffer on it. This is giving us no data inside of it on Intel. Okay, so we need a backup. Yeah, it's just when you do like modern graphics programming like we're doing here with a chunking system that the meshes exist on the GPU and we're doing things on the GPU and then reading them back to the CPU. Older hardware, specifically, you know, shittily developed hardware like Intel integrated graphics into a laptop, you know, just like they don't have the ability, their drivers just suck. They don't support much. The NVIDIA GPU in this laptop can still do it. Oh, I'm sorry, I hit the mic. It's old, but it has the capabilities because NVIDIA is NVIDIA. But yeah. The problem is I can just write this on Intel fine, but it's also going to be, this is like 5 milliseconds on Intel. So 5 milliseconds to do the upload and the download. So no persistent buffers, no persistent mapping. All right, I'm gonna get some dinner. I might be back later, I'm not sure, but I only plan to really stream for a few hours today. Anyway, I've fixed the chunking system 100% fixed now. Works flawlessly. There's no popping in and out. Problem is, I don't have an answer for Intel that isn't slow, and that might just be the pain. All right, peace out.